How do you find the equilibrium concentration when given initial concentrations and an equilibrium constant? So we're given this problem. Consider the reaction. Nitrogen plus oxygen becomes nitrogen monoxide. A reaction mixture at 2000 degrees Celsius initially contains 0.2 molar of nitrogen and 0.2 molar of oxygen. Find the equilibrium concentrations of the reactants and product at this temperature. Okay, so these are our initial amounts, and we initially start with 0 NO. Some of the nitrogen and some of the oxygen is going to react with each other, and it's going to produce some of our nitrogen monoxide. Then equilibrium is going to be reached, and the reaction and the concentrations of the nitrogen, the oxygen, and the nitrogen monoxide will no longer change once equilibrium is reached. The question is, when equilibrium is reached, what is the concentration? What is that equilibrium concentration? What is the concentration of nitrogen, oxygen, and nitrogen monoxide when the reaction is at equilibrium? So we're given this reaction. Nitrogen plus oxygen gas becomes nitrogen monoxide. And we're also told that Kc is equal to 0.10, and again, it's unitless. And we can create an expression for Kc based on our reaction. So again, like always, we do our product, and it's times 2, so it's squared, divided by the reactants. And this would be our expression for our equilibrium constant. Now, we have our equilibrium constant. We know it equals 0.1, and our goal is to figure out what is the concentration of nitrogen monoxide at equilibrium. What is the concentration of nitrogen at equilibrium? What is the concentration of oxygen at equilibrium? So we need to figure out what is the concentration at equilibrium. What concentration of nitrogen, oxygen, and nitrogen monoxide will give us an equilibrium constant of 0.10. So we are going to create an ICE table. The word ICE, I-C-E, in this case stands for initial. So I is our initial concentration, C is our change in concentration, and E is the concentration at equilibrium. So it's initial, change, equilibrium. So when we go back to the problem, it tells us that we start out with 0.2 molar nitrogen and 0.2 molar oxygen, and it doesn't indicate that we start out with any of our product, so we're going to assume 0 molar nitrogen monoxide. So our initial concentration for nitrogen was 0.2 molar. Our initial concentration for oxygen, I'm going to include sig figs, was 0.2 molar, and our initial concentration for nitrogen monoxide was 0. Okay, just to make this a little neater. Okay, so now we're looking at our change. This is the tricky part. We aren't given any information about our change. So we're going to say, okay, nitrogen is going to change by X. X number of moles of nitrogen is going to react. So nitrogen is going to lose, that's why it's minus, X moles of its initial amount. Now notice there is a 1-to-1 ratio between nitrogen and oxygen. So if 1 mole of nitrogen reacts, that means it would have to react with 1 mole of oxygen. So if X moles of nitrogen react, that means it reacts with X moles of oxygen. So X would also change, or oxygen would also change by losing X moles. Nitrogen monoxide, on the other hand, has this 2. So that means if 1 mole of oxygen reacted, 2 moles of nitrogen monoxide would be produced. So if oxygen loses X moles, then nitrogen monoxide would gain 2X. Because it has this coefficient, it gains twice as much nitrogen monoxide is produced for every mole of oxygen and every mole of nitrogen that reacts. So now we need to write our equilibrium. What do we have at equilibrium? Well, at equilibrium for nitrogen, we have 0.200 minus x, right? We start with 0.200, the change is negative x, so x nitrogen reacts, so x nitrogen is no longer there, so we lose that much nitrogen. The same goes with oxygen. We start with 0.200 molar of oxygen, and it loses x. So at equilibrium, we would have 0.200 minus x left of oxygen. And nitrogen monoxide starts at 0, and it gains 2x. So 0 plus 2x gives us 2x. So at equilibrium, we would have 2x nitrogen monoxide remaining. So now our job is, what is this x? What is the actual equilibrium concentration of each of these compounds? So this is when we go back to our equilibrium constant. Okay, so we know that our equilibrium constant is 0.1, and we know that that 0.1 needs to equal the concentration of NO at equilibrium squared divided by the concentration of nitrogen at equilibrium times the concentration of oxygen at equilibrium. So we are going to plug all of that in. So when we plug it in, the 0.2 for NO goes in the numerator, and again we're squaring that because of that coefficient, and the 0.2 minus x, so the 2x goes in the numerator, the 0.2 minus x goes in our denominator for each of our concentrations. And now we need to solve this. So let's start by noticing that our denominator is actually just 0.2 minus x squared because we're multiplying it by itself. So I'm just going to square that. Okay, and we need to figure out what x is. Well, we have something squared over something squared, so we can actually just say all of this is squared, and we can move the square outside. Okay, so now this is equal to, just to be clear, this is equal to 2x over 0.200 minus x all squared. Okay, and that equals 0.10. So what we're doing now is we will square root it, get rid of that square root, get rid of that square. So we square root both sides, and the square root of 0.10 is 0.316 equals 2x over 0.200 minus x. So now we need to get x out of the denominator, so we're going to multiply this by 0.200 minus x. So those cancel. We'll multiply this by 0.200 minus x. So now we have 2x equals 0.316 times 0.2, which is 0.0632 minus 0.316x. So let's put both x's on the same side. So we're going to subtract by 0.316x. And so we get 1.68x equals 0.0632. So we need x alone, so we'll divide by 1.68. Oops, that's not a 68. 1.68 divided by 1.68, and x equals, brace yourselves, x equals 0.0376. So that's what x equals. So now we are almost done. We go back to our ice table and we say, okay, well, the concentration for N2 at equilibrium is 0.200 minus X. Well, X equals 0.0376. So that means that the equilibrium concentration for N2 at equilibrium is going to equal 0.200 minus 0.0376, which gives us 0.162. And it's concentration, so we need molarity. The same thing goes for our concentration of oxygen. At equilibrium, it is equal to 0.200 minus X, which is minus 0.0376, which equals 0.162 molar. Okay, so that's our concentration for oxygen. Here's our concentration for nitrogen. And nitrogen monoxide is equal to, the concentration of nitrogen monoxide at equilibrium is equal to 2 times X, or 2 times 0.0376, which is that equals 0.0752 molarity. So those are our answers. And this is how you do an ICE table.